At today's presentation, we will talk about a systematic literature review validation methods for artificial intelligence systems. So first of all, I am Mohammed Abdullah, and this the module that we are going to do, and this is administration number. So, so first of all, we are going to describe what's artificial intelligence. So we're going to talk about artificial intelligence that has taken a site like a storm. Autonomous systems provide us with recommendations of what to watch, where to travel, and where to eat. And there are some AI libraries that can implement easily, like TensorFlow and Python. And also, in particular, machine learning currently is a trend in AI paradigm that has sparked roadmaps and research on how learning systems should be and are developed while ensuring their correct functionality. So as we all know, so artificial intelligence has made a significant impact on our society, revolutionizing various aspects of our lives. So one area where AI has gained a considerable attention is in the development of autonomous systems. So what do autonomous systems do? So autonomous systems have the ability to operate and make decisions on their own without a human intervention. So at the center of the autonomous system is machine learning, is where an application can learn and improve from data and experience without being programmed to do so, and with a minimal to human contact. So this technology is fundamental to be able to predict, plan, and sense the environment that has become more integral part of our daily or minimal impact to human. This is environment to be able to predict and sense. So with the field of AI, machine learning has emerged a prominent and widely adopted paradigm. Machine learning algorithm allows systems to learn from data and make predictions or take actions based on that learning. This has led to extensive research and development efforts focused on design and improving learning systems to ensure their accuracy and functionality. So machine learning has become a driving force behind the development of artificial intelligence. So now we come to the definition of AI. There are numerous definitions for AI. IEEE USA defines AI in IEEE follows. So artificial intelligence is the theory and development of computer systems that are able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, learning, decision making, and natural language processing. And it's also important to know that what we mean by validation is not the same as a machine learning model validation. Machine learning model validation often means testing the generalization, the generalization ability of a model. So according to this definition, AI encompasses the theory and development of computer systems that possess the capability to perform tasks that typically require human intelligence. Those tasks include like here we are, I have taken before. They include visual perception, speech recognition, learning, decision making, and natural language processing. So when it comes to the concept of validation in the context of AI, it's important to distinguish it from validation of machine learning model. So a machine learning model validation is assessing the generalization ability of a model, which involves evaluating how well the model can perform on unseen or new data. This process aims to ensure that the model has learned patterns and relationships from the training that can be applied to a new instance effectively. So another way, validation in the broader context of AI may encompass a broader range of activities It can also involve testing the functionality, performance, and the accuracy of AI systems as a whole, beyond just the validation of individual machine learning models. So what is the aim of this paper? So this paper aims to gather a holistic view on the validation of practical AI systems and applications. By practical, we mean a complete system that performs a reproducible function in a realistic context. Henceforth, AI systems and applications are referred to shortly as systems. Focusing on practical AI systems could help to both improve the state of research in general and to allow more practical research to take the leap into actual practice. So now we are talking about the objective of this paper. So what is the objective? So the objective is to provide a comprehensive understanding of the validation process for practical AI systems and applications. So what do we mean by this term practical? So practical refers to the complete systems that serve a specific purpose in real-world context. Those systems encompass the entire AI pipeline, including data collection, preprocessing, model development, deployment, and utilization. So throughout this paper, we will also talk about the word system. So this word system is used as a shorthand reference to the practical AI systems and applications. So focusing on the practical AI system, this paper also aims to contribute to the advancement of research in the field this field of AI as a whole. It also recognizes the importance of bridging the gap between theoretical advancement in AI and their practical implementation. So by studying and utilizing the validation of practical systems, researchers also gain insights into the challenges and considerations that rise when translating AI research into a real-world application. So this understanding can also lead improvements in the state of research and enhance the applicability and effectiveness of AI systems. So moreover, the paper also emphasized the significance of enabling practical research to make a meaningful impact in the real world scenarios. So in this slide, we are going to differentiate two models, machine learning model validation and a continuous validation. So machine learning model validation often means testing the generalization ability of a model, while continuous validation of the service deploy the system and is applied to ensure that the AI system also works in situations unseen during development or in training data, essentially testing that the AI systems operate as intended. So machine learning model validation primarily focuses on evaluating the generalization ability of a machine learning model. It also involves assessing how well the model can perform on a new unseen data that was not seen during the model training phase. So there is a goal. What is the goal? So the goal is to determine whether the model has learned patterns and relationships that can be applied effectively to new instances or scenarios. So this validation process helps ensure that the model can make accurate predictions or decisions in real-world applications, while continuous validation is a practice that involves ongoing monitoring and observation of a deployed AI system. It's applied to ensure that the system functions as intended and performs well in situations that may not have been encountered during the development training phase. So also this continuous validation involves collecting feedback and data from a deployed system, then analyzing its performance and making any necessary adjustments or improvements to maintain its functionality and accuracy. So by continuously validating the AI system, developers or other operators can identify any deviations, errors on its behavior and take corrective actions to ensure to ensure that it's functioning properly. So now we come to the validation. What is the validation? The conceptual piece of validation as applied in this paper stems from the IEEE standard that defines validation as an activity that ensures that an end product stakeholder has met the true needs and expectations. So there is a problem. What's the problem? The problem in validation is to begin to stack up when attention is turned to special characteristics of AI systems compared to traditional ones. So in the context of this paper, the validation process is based on the conceptual definition provided by IEEE standard. So according to this standard, the validation is an activity that ensures that the end product meets the true needs and expectations of the stakeholder. So in the case of AI systems, this validation process becomes more complex due to the unique characteristics and challenges associated with these AI systems. So AI systems have special characteristics that differentiate them from traditional systems leading to specific challenges. So one other challenge that validate AI system is their complexity and lack of transparency. So related work. The validation has been shown to be problematic for AI-based systems. So there is this community literature review about software engineering challenges for machine learning systems. It reports that validation was one of the major difficulties reported in the literature related to machine learning systems. Sorry. So this is paralleled by this slide that's well go at that was 2002 argues that the difficulty of setting that required level of assurance and criteria are among us the major challenges in ensuring that the quality of software utilizing AI. So these challenges may arise from many qualities quintessential to AI systems. One of them is being called the Oracle problem. So what does this mean? The validation is indeed poses challenges for AI-based systems as highlighted by various studies and research in the field. So we will follow this communist literature review. So this review, software engineering challenge for machine learning system and also the other one, Geo at work ensures that the quality of software is utilizing AI, both knowledge, the difficulties associated with the validation. So this Oracle problem is one of the challenges that arise in the validation of AI systems. This Oracle problem is to refers to the difficulty of determining the ground truth or the correct answer against which the AI system's performance is evaluated, unlike traditional software systems where the expected outcome or behavior can persistently divided. AI systems often deal with complex tasks and uncertainties, making it challenging to establish a definitive oracle or reference for validation. So now we come to the research questions. So in this work, we will seek answers to the following two research questions. The first question is what kind of practical AI systems and their characteristics are presented and validated in the research literature? The second question will be what kind of validation methods are used with practical AI systems in the research literature. So this first question focus on exploring the types of practical AI systems and their characteristics that have been discussed and validated in the research literature. Also, this question seeks to identify the diverse range of AI systems that have been developed and studied along with their specific characteristics and functions. So the main goal of this question is to understand the realm of current research. Knowing what kind of system are handled in the research literature, it also helps to understand not only what's being covered, but also where research gaps may exist. So the second question also aims to investigate the validation methods that have been employed in the research literature or assessing practical AI systems. This question focuses on understanding the different approach techniques and methodologies that research have utilized to violate the performance and functionality of AI systems. So we'll come to the research methodology. So I'm going to explain this graph. So this literature series was conducted with 4 databases. What are the 4 databases? So this 4 databases, they are called Scopus Web of Science, ACM Data Library, and IEEE Explorer. And this one is using semantically the same shared string after the search of the series of the 3 selection stages. These are the 3 selection stages: stage 1, stage 2, and stage 3. So that they can introduce the initial set of one of this year. They will use this one 1164 1164 preliminary papers. So the first phase of this research is the selection process. So the selection process was to gather the initial set of papers by searching scientific databases, research strategy, and then to research strategy. So the following strategy was revised, and the following steps were taken to consider the research. The first one is to identify the general terms, and the second one is to identify synonyms and alternative forms. And the third one is to identify prominent domains that utilize AI in serial literature. And then next one is to identify terms associated with, and then to identify terms that imply usability and stereo relevance. So if the database allows to use well-regarded research terms when resourceable, it will exclude the research, and then it's already found in the previous database. So what are the 3 stages of this graph? The first stage is this one, 1,164 preliminary papers. So for the research, we were assessing and included using this inclusion criteria found here. And the second stage is the remaining 372 included papers were assessed and excluded the exclusion criteria. And at the third stage, the remaining 140 papers were assessed based on their relevance resulting, so that it will set the final 90 papers. And then here I'm going to talk about 3 validation methods. The first one is quantitative analysis. Is a validation method used to assess the performance and effectiveness of practical AI systems. It also includes the use of numerical measurements and statistical techniques to analyze and evaluate the system's output behavior. And the next one is descriptive analysis. It focuses on providing a detailed description and assessment of the characteristics, features, and behavior of a practical system. And the last one is descriptive analysis of continuous variables. The specific application of descriptive analysis in the context of practical AI systems. In this method, continuous variables such as numerical or quantitative data are analyzed and summarized to understand their distribution, certain attendance variables, and other statistical characteristics. So there are some periods of validation. The dominance of machine learning in the results poses a threat to generalizability of the results. As most papers present a system utilizing machine learning, the results would suffice to interpret as a result concerning machine learning literature, not AI in general. The school results could be due to the search terms like machine learning and validation, usually going hand in hand, and also it's not uncommon for technologies to lose their status as artificial intelligence and not be revered to us anymore, thus leaving the state of machine learning to roam free. And another threat of violence is bias. So of course, it's potential threat in other terms as well. So thank you. This was the last slide, and Assalamu alaikum.